Alright, hey guys, today is the last section on limits, 13.3, one-sided limits and continuous functions. So the first page just kind of gives you an overview. You can read through it about what it means for a limit to exist, what it means for one-sided limits. We've gone over this before, but if you see as x approaches c and then a little negative sign, that means x approaches c to the left, and then a positive sign is x approaches c from the right. So that kind of gives you some stuff to read through. If the limit as x approaches c from the left equals the limit as x approaches c from the right, then the limit exists. And if they're not equal, then the limit does not exist. So we're going to go through a few examples of that. All right, so the first one gives us a graph, which is pretty nice because we can look at it visually. So the first one says, and just as a reminder, the limit as x approaches 2, this means from the left, this means from the right, and if you don't see a sign, that just means the limit as x approaches 2. Now it gives us the function algebraically, and we'd have to either graph it, or this would be x is less than 2, that would be the left, the right, and then this is where x actually equals 2, so you can see that point there. Okay, so we can see the graph. Alright, so x approaches 2 from the left. So that's like I am coming from the left side. So sometimes people can get a little bit confused on this, but it's like I am walking to 2 from the left side. Okay, so I'm coming this way from the left side and I'm approaching this value right here, and that is at 1, 2, 3. Alright, and then this is from the right side, so I'm coming from the right side towards 2, and that's going to be 0. Now, we have a little bit of an issue here because you notice the limit as x approaches 2 from the left does not equal the limit as x approaches 2 from the right. Therefore, this limit does not exist. Now, you need to remember Mean Girls here. I know I've referenced this twice now, but a limit does not exist, okay? That is a particular kind of notation, you might say. Limits don't exist, and we'll get to later. If it's a function, if it's a point, we say that's undefined. So D and E, you can abbreviate that, or does not exist, but that is the particular notation that they'll be looking for, okay? So the limit as x approaches 1 from the left. Now this one doesn't give us a graph. We could graph it. However, we also know that's just a line. So, I mean, this is obviously not exact, but we can see anything that it's going to approach the same thing from the left and the right. So I can use my algebraic techniques here, and I can plug in 1, 2 times 1 minus 5. 2 minus 5 is going to be negative 3. Okay, because that's a line, it's a polynomial, I can use my technique there. Alright, this one right here. Now if I were to plug in 1, I would get 0 on the bottom, and I would get 0 on the top, so that's not going to work. So I'm going to factor it. So x squared minus 1 over x minus 1. Okay, I'm going to have to keep factoring. X plus 1, x minus 1 over x minus 1. So I get x plus 1. And now I can plug it in. So 1 plus 1 times 2 is 2. Okay, and that's going to equal what it approaches from the right. Alright, so continuous. So continuous just in general means can I draw it without picking up my pencil? So the limit as x approaches c from the left equals f of c, so that's the point where it actually exists. And the same thing from the right. And you see there, so this gives you a little bit of kind of overview. I'm not going to read through everything. You can read it on your own and let me know if you have questions. But again, this is where I pointed out before, f of c is not defined right here. So if we say a point is not defined, you can say undefined, that's fine also. But a limit, we say exists or does not exist. Okay? Alright, so we did this a little bit back in our rationals unit. Because you can see this right here is a rational function. So we're going to determine which numbers it's continuous and then use limits to analyze the graph. So the first thing I'm going to do is I'm going to just factor this. X minus 2, x minus 4. So I can see I have a hole at x equals 2. Let's make sure that lines up with my graph. Yes, and I have a vertical asymptote at x equals 4. Okay, cool. So which function, or where it's continuous? So negative infinity to 2, not including 2 because there's a hole there, and then 2 to 4, not including 4 because there's a vertical asymptote there, and then 4 to infinity. So that's where the graph is continuous. Alright, so then we're going to use limits to analyze the graph, and so I'm just going to analyze it at 2 and at 4 because those are my places where it's not continuous. Okay, so I'm going to do this in 2 different ways, okay, or I guess in 4 different ways, I should say. So I'm going to do the limit from the left, the limit from the right, the overall limit, and then f of 2 and f of 4. And so you'll see what I mean in a second. So it's going to be a lot of writing, but the limit as x approaches 2 from the left of f of x, and I'm just going to write these all out. Please notice my notation here. This is important. A lot of people forget this f of x. Don't forget it. Alright, so I'm going to do this right here, and then I'm going to do the exact same thing for 4. So I'm going to go ahead and write that out so I have that there, and then I can just talk through it. Also notice, I don't know why this is a common mistake, but 2 from the left, notice I'm not putting negative 2. This is 2 from the left. It has nothing to do with negative 2. Negative 2 has nothing to do with what I'm analyzing here. Oh, and notice, see, I just made a mistake, like what I said not to do, and I didn't put f of x. Okay, cool. So the limit as x approaches 2 from the left, so as I'm coming from the left side, it's going to approach, I should say, negative 1/2. Okay, from the right side, if I'm coming from the right, it's also going to approach negative 1/2. Okay, now since the limit from the left and the limit from the right are equal, the limit as x approaches 2 is also going to equal negative 1/2. Even though, if we look at f of 2, you see that there's a hole there, so f of 2 is undefined. Okay, but as long as the limit from the left equals the limit from the right, then the limit exists. Okay, now 4 from the left. So 4 from the left. So if I'm coming from the left side, okay, I can see that I'm approaching negative infinity. 4 from the right, I can see that I'm approaching positive infinity. Well, these are two different values, so therefore the limit does not exist. Remember, limits don't exist, function values are undefined. Okay, so f of 4, so that value right here, it's an asymptote, it's undefined. Okay, so that's it for that one. All right, last one, determine the values at which the function is continuous. So we just have one place right here that it's not continuous, but also I'm going to notice that this function actually stops at 5. So I have negative infinity to 0, not including 0 because it's not continuous there, and then 0 to 5, bracket on 5, okay, because it actually stops at 5. All right, it doesn't say to analyze with limits, but I'm just going to do the limit, the same exact thing I did up there for 0. Okay, so limit as x approaches 0 from the left, and this is f of x, so we want to make sure that, oh, and actually the other function, it should have been r of x. Whoops, I'm not going to go back and change all those, but 0 from the right, 0, and then f of 0. So I'm going to go ahead and do f of 0 while I'm here. F of 0 is where the function is actually defined, and this one is defined. I see a closed circle, and that is at 0. Alright, before I can do the overall limit, I need to find the limit from the left. So as I'm coming from the left, it equals 0. As I'm coming from the right, it equals 1. And the limit overall, well, it's different from the left and the right, so the limit does not exist. Okay, and so that's it for limits, one-sided limits, and continuous functions.